Hi all, I am Sandeep and welcome to my YouTube channel. I hope all of you are doing fine. Today we are going to build one multimodal RAG AI application with Python, Voyage AI and KDB.AI. And it's going to be very exciting, and please make sure you watch this video till the end. So let's dive in. Okay, so this is multimodal RAG AI application with Python, Voyage AI and KDB.AI. So in this project, a multimodal RAG AI application we're going to build with Python, Voyage AI and KDB.AI. So you might have heard about RAG, Retrieval Augmented Generation, but in multimodal RAG system, it stores and retrieves both text and image data using a vector database. So in this project, we are dealing with text and image data, but in reality, you can have the combination of any two type of data. Let's say text and audio also. It could be text and audio, it could be text and image, or any two combinations or different types of data actually in multimodal RAG it deals with. So basically in multimodal RAG, it stores and retrieves to different kinds of data, let's say text and image, okay, using a vector database. Then we use one multimodal LLM, large language model, to generate a response based on the retrieved data, that is the image plus text, and also user's query based on that. So our goal is to embed the images and text into a unified vector space by using multimodal embedding model to enable simultaneous vector searches across both media types. So basically in multimodal RAG, our goal is to first embed the mixed type of data, let's say text and image. We have to embed them and then store them in a unified vector space. Okay, and then we'll do the simultaneous vector searches across both media types, text as well as image. So this embedding is done by multimodal embedding model. So here we basically convert the data into a numerical vector representation. Both image and text, we convert the data into numerical vector representation and then store them in the KDB.AI vector database. In this project, we are using KDB.AI vector database. So multimodal LLM can then be augmented with the retrieved embeddings to generate a response based on the user's query. The multimodal embedding model used in this project is Voyage Multimodal 3. So it was developed by Voyage AI. So Voyage AI, this model, Voyage Multimodal 3, this we are going to use for multimodal embedding. This Voyage AI Multimodal 3 can be embed data modalities including text and images. So what is the first step here? The first step is to create the data. First images, create the images and their corresponding text data. Then some brief description about those images. Okay, you have several images and their corresponding description, some brief description written in the text about those images. So you have to prepare the data. So you have to prepare them and keep them in two different folders. And here, the orders, the names of the images and the names of the text data both should match. The naming convention is very important. The names of the image as well as corresponding text data, they should match. They should be kept in the proper order in the folders. So first step is the preparation of this image and text data. And for database, we'll be using the KDB.AI vector database. So you can get free API key for both KDB.AI as well as Voyage AI. And for KDB.AI, you will also need the endpoint URL that I will show you. So in this app, the user can write a query in the query text box, and then they just need to click on this multimodal search button. There's a button called multimodal search in the application. So they have to just click on that after writing the query. So what it will do, it will first create the embeddings of our multimodal data, that is image plus text. It will first create the embeddings of our multimodal data, image plus text, and then store them into the vector database, KDB.AI vector database. After that, it will also convert the user's query to a query vector, that is embedding. And then it will go on searching in the vector database based on the user's query, and it will find the best matched image and also its corresponding text. And finally, it will give the response to the user. Okay, that's the way it works, this multimodal RAG. It has a lot of interesting practical applications. In our present project, just we are storing some, let's say, animal or creatures, some data and their corresponding images, and we are dealing with that animal images and their corresponding text file containing some description or features about those animals. But in reality, you can, you'll have to deal with some product catalogs containing a lot of products and their, descriptions or some features so written in the text. So in that case, in that situation, it will be very useful to store them, all the products, whatever different products, and then their, the brief description about the products. The description may contain some important features about those products, etc. All these things you can store them in vector database, and later you can do semantic search, and get retrieve the required information from the vector database based on the user's query, etc. Okay, I'll show you a diagram here as I have already explained to you. So you have the text, you have the image, you have the image or corresponding text, and then using multimodal embedding model, multimodal embedding model. In our case, it is Voyage multimodal 3. This model developed by the Voyage AI will be using for the multimodal embedding. So it will do the embeddings of this text and image data and combine them, and then it will we will have this vector representation of this vector embeddings of this combined data, image and text, and then it will be stored in the vector database. Okay, so now I'll just take you to this site, this Voyage AI. For getting the free API key, you have to first go to this dashboard dot, as you can see, voyageai.com, and then you go to this API keys here, and then you have to create your, but before that you have to sign up. You can sign up with your Google account, and then you can get your free API key. Just click on this new create new secret key, and then you save it, copy it and save it somewhere. And you have to then add the environment variables that I will explain later. And your .env file is also there. You have to just add this API key to this .env file with the proper environment variable name. So you have to do it for both Voyage AI, and also you have to go to this KDB AI cloud side, this one, and like cloud.kdb.ai, as you can see, you have to go to this site, and then here also you have to sign up using your Google account. Then you can get your free API key and also the endpoint URL both. So as you can see that here we have the API key, free API key, and also you can get this endpoint URL. So this is my endpoint URL. So these two things you will need, in order to use this KDB.AI database. So endpoint URL and API key, free API key. So once you have them, both the endpoint URL and API key, you have to store them in .env file with the proper environment variable names, .env file. This is very important. And I will also show you how we are storing this image and text data, image data, and text data. So in our working directory, we have a folder called data, and if you go inside that, and you will find two folders, namely images and text. So images contain some, that animals or creature images like bat, bear, caterpillar, deer, and also we have the corresponding text file for them containing some brief description about those animals or creatures: bat, bear, caterpillar, deer. And naming convention, you have to follow so that name should match, that image name and text name should match, and they should be in the proper order. So once you have the data and you have the API key and endpoint URL, all these things which I have already explained, you are good to go. So later I will explain to you the entire code, but before that, let's see let's launch this app and see it in action. It's going to be very exciting. So it's a Streamlit application, Streamlit app. And so for just launching the Streamlit, run and the name of your Python script, that multimodal underscore RAG underscore app.py. Then when you just launch it, it will take some time and then it will appear. Yeah. So this is how it looks like, multimodal RAG AI application with Voyage AI and KDB.AI. And here you have to write the query, and then you have to click on the. So I suppose I can write any query. Let's see. Let's say just find a mammal that can fly. Okay, so what it will do, then you will have to click on the multimodal search. So first thing is, it will first create the embeddings of the image data, text data, and store them in the KDB.AI vector database, and it will then convert our user's query to query vector corresponding embeddings, and then it will go on searching in the database, and it will find the most relevant or the best matched the image and corresponding text based on the user's query, and then it will display here. So if I like type a query like find mammal that can fly, so it will definitely find the best matched image and its corresponding text description. So if I click on multimodal search, it will take some time, but I already have done it, and so I can show you the results directly here. So when you type find mammal that can fly and then click on multimodal search, it will uh, basically give you these results. So through cosine similarity search in a vector database, it found the right best matched image, that is the bat, and its corresponding text. So it says bats are the only mammals capable of sustained flight. They are capable of flying. Bats are the only animal, and then this description is about the bats only, and so our result is correct. It could find correctly in the vector database, and then the right image and the corresponding text. So you can also give other query also. But in our, we just stored the images of the four animals and then corresponding text files or descriptions. But in reality, you can have many like products or other objects also. There images and corresponding text, and you can store them in a vector database and do the multimodal search. You can for many practical application, you can use it depending on your requirements of project. Okay, so it will also print it on the console, as you can see. So it's good to print on the console also. Now I will explain to you the code in details. Okay, so first you have to import all the necessary libraries, pandas, then PIL Python imaging library. Then from IO you have to import the bytes IO, import operating system OS, then .env. From .env, this you have to import load.env. As you know, this is required for the environment variable load.env. Streamlit. We are going to build the application using Streamlit, so import Streamlit as ST. Then Voyage AI import client. From the Voyage AI, you have to import client, and then KDB.AI client. This is for the database KDB.AI client. Import KDB.AI. I'll also show you the requirement.txt where I put everything, all the necessary libraries, etc. for your reference. So pandas, PyMU, PDF you require. This is a very famous PDF library, commonly used. Then Pilo, this is Python imaging library. Then KDB AI client. Then Voyage AI, .env and Streamlit. Okay. So after importing all the necessary libraries, then you have to load the environment variables. So your environment variable contain all the necessary environment variables like for the API keys, etc. So model we are going to use, as I already explained to you, that is Voyage Multimodal 3. This is the multimodal embedding model from Voyage AI. Then we are first initializing the client, the VO equal to client. We are passing the API key that we already stored in the environment variable. As an environment variable, we already stored in .env file. So os.environment, and then this Voyage AI underscore API underscore key, we are passing this API key, get an initializing client, and then we have several functions. First function is to read the text file. So it will read just basically the content of the text file, and then it will return this text. And then this one function to create the embeddings for text and image data. This is a very important function, and this is data to embedding. Here will be first passing that data as an argument, image and text data, and then it will return the embeddings, multimodal embeddings, that result.embedding. So how it is doing, like a result equal to VO, that VO already we have defined here the client Voyage and VO dot multimodal underscore embed. Then you have to pass this input data in this one, and then model name already you defined above, and then input type equal to document, and then return result.embeddings. So it will return the embeddings for both image and text. Now you have to define a data frame to put our embeddings and metadata into it. So we are going to create one data frame, and data frame there will be 3 columns: path, media type, and embeddings. The path, it will be either the path of the image data or text data. Media type, it will be either image or text. The embeddings that I will explain to you. So first get a list of the paths for both image and text. So images, os.listdir. If you do os.listdir and then path.data /data and images, so it will create the list of all the images from this images folder, and then it will create the list of all the text file from the text folder. List of text and list of images you got. Now you have to empty list, you have to define that image data and text data, where you will be appending all the image data and text data. Then look through the images and extract them, and then add them to image data, and then append path, media type, and the empty embedding to the DF. So for each and every image in the image, these images, the list of images, each and every images basically as path, it will be the base path plus the image name, that's something.jpg. So you got the path of the image, then you have to like open each and every image here, and you have to create the PIL Python imaging library object, actually image object. So that where you are doing, and you are resizing it to this size 256 by 256. But it is reading as a bytes, image bytes, and then we are basically opening it in PIL Python imaging library, the image.open, and then resizing it. And after that, we are appending the data to this image underscore data, this list. But we are appending as a list. So it will be the list of list finally. So each and every row, new row will be the path, you know already, path of the image, and then media type will be image, and embedding we are keeping it empty first, later we'll be adding. And then we are adding this new row, pd dot concatenate concat to the original df. We are adding this new row. Okay, similarly we are doing the same thing for the text data also. So we are adding the new row, and then this for this text each and every, and also text data we are appending to this extract this text data, this list as a, it will be list of list. So finally you have the image data and text data in the list, you know, list of list, and we're adding this data both, the combine the extracted image and the text data for embedding. So embedding, we are combining both image data and text data, you know. So these embeddings, we are basically calling this function data to embeddings and passing this data both. It is a combination image data, text data, then we are getting the final embeddings, combined embeddings, and these embeddings we are putting here under this column, df column. Now you can understand we earlier this defined this empty column, created this empty column embeddings, then we are adding the data here, putting the data per column data. So now our df data frame is complete. It contains path, you can see the type, data type, whether it is image or text, then it contains the embeddings, then we are returning this df. So next function is about the vector database. So we are connecting to the KDB.AI, that's storing the stored data vector db. This is the function. So here the session will be KDB.AI dot session. Then you have to pass the two things. One is the KDB.AI API key, another is the KDB.AI endpoint URL. So endpoint, and then API key you are passing, then getting the session. From the session you are connecting to the default database, you know. So once you have the database, then you have to, you know, define, set up the table with the three columns. So what are those columns? A path, media type, and then embeddings. The table schema you have to define, because you are going to create a table in the database, okay, for storing your data, right? Then you have to define an index. You know, the database, you need to create index. Index will be on this column, the embeddings column, you know. And then dimensions, what will be the dimension of the embedding? So length of the embedding is 1024. And the metric will be CS. CS stands for cosine similarity, because later we'll be doing cosine similarity search. So it is cosine similarity. Column will be embedded, and then type of the index is a Q flat. Q flat is a kind of, you know, index type commonly used in the KDB.AI. So you got the index, you got the table schema. So first you have to make sure that table doesn't exist already. If it existing, you have to drop it. So every time you have to create a fresh table latest. Okay, now next thing is the db.create table. Then you have to pass the table name and then schema and then index. The table is created. Okay. After table is created, your next step is to insert the data into the table. So for doing that, we are just splitting it into the 2000 row batches. So every 2000 row batch, we are just in batches we are inserting the entire data in the batches. Okay, 2000 row batches. So then we are returning the table. So your table is complete now. Okay. Next thing is to write a function for query to embedding. So user query will come, you know, then after you get the query from the user, you have to convert it to the query vector. That is embeddings, and this function is doing exactly that. It will return this query vector. Okay. Next function is to view the results of our similarity search. This is for the viewing the results. Once you have the results, then you have to view it. For viewing, this function is written, and here as you can see, we are saving the image that has been already um, that image has been extracted from the database, and also the text that is also found from the database, the matching text and image, whatever, based on the base search result. So both we are saving in our working folder on the disk, result.txt text file, and also the result image.txt file. So this is for the viewing results, this function. Now this is a small function, is very important, the multimodal search functions. So for that we are passing the query vector that user based on the user's query, and also the database table. So then it will generate the results, and it will do the table.search. It will search in the table, database table, and it will get the results, you know, and it give an equal to get the best matched results. Then view results, it is returning, sorry, it is just calling this function view results, and we are getting our results saved here, image as well as text. Then we are coming to this main, that is the Streamlit part. The front end part is written in Streamlit. And here we have the title, Multimodal RAG AI application with the Voyage AI and KDB.AI. After that, we are adding an image logo here. And then you have user's query, that st.text input. You are giving the text input, user query is getting stored here. And then finally, you have this button, multimodal search. As soon as user will click on the multimodal search, it will first, create, call this function, create underscore data frame. Data frame will be created based on our data stored in the folders, image and text folders from a local area. It will create the data frame, then it will pass the data frame and call this function. Stored data vector, it has then the database table is created, and our data is stored. Then query vector, that user's query will be converted to the query vector. Then multimodal search function we are calling, we are passing this query vector and then table. Then finally we are getting our result saved or stored in our local disk, in the form of the image will be stored with this name, results underscore img.jpg, and then results.text part will be saved with this name, results.text, and then later we are opening it, and then we are displaying the results in the Streamlit application. Okay. Then finally, like you see it here, you see the image as well as the corresponding text. Okay, that's all for this video. I hope you liked it. If you like, please give a thumbs up. It will encourage me and motivate me to create more such videos for you in the near future. And also, please do subscribe my channel if not done already. And also, please write your comments and feedback. It's very important for me to know how you think about these projects or this work. Your comments or feedback is very important to me. So please write. Please find 1 to 2 minutes time to write your comments or feedback, and please do subscribe my channel. Thank you very much for your time. Thank you. Take care. Bye.